Hi everybody, it's Miss Austin and I'm going to be going over the Unit 5 Lesson 6 practice problems. My volume might be down. There we go. All right, so we're talking about symmetry in graphs and whether a graph or a function is even or odd based on its equation today. So I've got a little reference we can use up here. If f of x is equal to f of negative x, then we know that the function is even, and if f of x is equal to negative f of negative x, it's odd. So we're going to start out by seeing if it's even, and then we will move on from there if it's not even to check if it's odd. So we need to see if we substitute x with a negative x if we get the same thing. So everywhere I see an x, I'm going to replace it with negative x. And then, okay, so basically wherever I saw x, I put a negative x, and now I'm going to evaluate that. Negative x to the fourth power would change back to a positive. Negative 4 times makes a positive. And now I stop. Is this answer the same as the original? Yes, it is. So that means this is even. All right, moving on. Second one, same thing. We're going to start and we're going to check what we get when we do f of negative x. So everywhere I see x, I'm going to replace it with negative x. So negative x to the third power would become negative x to the third, and a negative 4 times a negative x would make positive 4x. Is f of negative x the same as f of x? No, so it's not even. Now I'm just going to keep going. To check if it's odd, it says that the negative of this would be equal to f of x. So let me use a different color here. I'm going to just keep going right on top of this problem. I'm going to multiply this by negative 1, everything by negative 1. So that would be, running out of room here, negative f of negative x equals, that would become positive x to the third, and that would become negative 4x. Now I'm going to compare this one to the original. Is this the same as f of x? Yes, it is. That means it is odd. If f of x is equal to negative f of negative x, then we know our function is odd. Letter C, everywhere I see x, I'm going to replace it with negative x. I'm testing f of negative x. That would become 1 over negative x squared becomes positive x squared. So is f of negative x the same as f of x? Yes, it is. So this function is even. All right, oops, a little blurry. Letter D. I'm going to start with f of negative x. Wherever I see x, I'm going to replace it with negative. All right, this would become positive x squared minus x minus 3. Is f of negative x the same as f of x? No. So now I'm going to continue on to see if it's odd. To see if it's odd, I need the negative of this. So I'm going to multiply the entire thing by negative 1. So I'll put no on that. So here we go. I have negative f of negative x equals negative x squared plus x plus 3. Is that the same as f of x? No. This function is neither even or odd. All right, number 2. Here's a graph of the function f for x greater than or equal to 0 and less than or equal to 5. A, The function g is even and takes the same values as f for x is greater than or equal to 0 and less than or equal to 5. Sketch a graph of g. If this is even, right, then all I'm going to do is switch my inputs. When it's even, the original function is equal to f of negative x. I'm switching my inputs. So I kind of like tried to find some points here. A little hard. It's not the greatest grid. That looks like almost 5 and 100. So it's going to be negative 5, 100. It's not perfect, but just trying to use it. I'm just switching, right? This is about 5, 100. So it'd be negative 5, 100. Then I found this one, maybe like 3.5, 50. So negative 3.5, 50. That kind of gives me enough to put the curve in here. So this is G. Even. The function h is odd and takes the same values as f for x is greater than or equal to 0 and less than or equal to 5. Sketch a graph of h. Odd functions switch the input and the output. So I've already kind of found these points. This is 5, 100. So then it would be negative 5, negative 100. It's a reflection across the x and the y. So it's right there. This one was about 3.5, 50. So it'd be negative 3.5, negative 50. I'll use a dotted line for this one. And then it would continue on up. It'd be that graph. This is h. Okay. G is even. H is odd. All right, moving on. Number 3. The linear function f is given by f of x equals mx plus b. If f is even, what can you conclude about m and b? So if you remember from algebra 1, y equals mx plus b is a line. So I was just kind of thinking about this problem. There's a line, right? Well, in order for this to be even, the only thing that gets switched are the inputs, right? So it's going to have symmetry across the y-axis. Well, the only way, right? I mean, this does not have symmetry. You'd have to have something like that, which is an absolute value graph. That's not linear. And I mean, even if your slope's going downhill, right? That doesn't have symmetry. Oopsie. Hang on, guys. Here we go. Minor technical difficulties. If your slope is positive, no symmetry across the y. If your slope is negative, no symmetry across the y-axis. So really the only way you could have a y equals mx plus b that is even is if it looked like this, right? And that means, I don't know if you remember from Algebra 1, that your slope is 0. This is a horizontal line. Like maybe this is y equals 3. Or you could have a line down here, like y equals negative 5. But bottom line, in order to have symmetry, the slope would have to be 0 in order for it to be even. Number 4. Here are the graphs of f of x and f of x minus 1 for a function f. Which graph corresponds to each equation? Explain how you know. Well, I try to find 2 points that I can easily compare. So my eyes gravitated towards this one and this one. So I can tell the green graph, if I shift it 1 to the right, it becomes this blue graph on the right-hand side. And shifting a graph 1 to the right is this. So this blue graph is the green graph shifted 1 to the right. So the blue graph is this one right here. This is the f of x minus 1. So it shifted 1 to the right. And then this green graph is the original f of x. Oh no, guys. Here we go. I don't know how long ago that cut out. I wasn't paying attention. Okay, the blue graph is the green graph shifted 1 to the right. So the blue graph is the f of x minus 1. The green graph is f of x. Number 5, write an expression for 2 of the graphs. Well, I'm just going to do them all. So I'm going to get them all ready here. We have A, we have B, we have C, and D. And we're basing these all on this one right here. So to get A from this one, I need to take f of x and shift it 1, 2, 3, 4, 5, 6 to the left. 6 to the left would be a plus 6, f of x plus 6. To get B, I need to take f of x and shift it up 2, f of x plus 2. To get C, I have to shift f 1, 2, 3, 4 to the right and up to 3. 4 to the right, up 3. And finally D, I have to take f and move it 1, 2, 3, 4, 5 down. Right? To move a function left or right, you put the number in with the input, and it's opposite of what you would think. And to move a graph up or down, you put the number at the end, which affects the output. All right. Last one. Number 6. Here is a graph of the function given by f of x equals x to the third. What happens if you reflect it across the x and the y? Now, Miss Austin has a little bit of a cheating advantage here because I have some tracing paper. I mean, you could also just like pick a point. I'm going to show you with tracing paper too, but I imagine if I took this point here, which is like 450. So if I reflect that across the x, that would become 4 negative 50. Now if I reflect that across the y, I'm going to get negative 4 negative 50. Try, what's this one? Maybe 325. So 325 becomes 3 negative 25 across the x. Sorry, guys, I don't know what's going on. So 325 becomes 3 negative 25 when I reflect it across the x. Now across the y, it would be negative 3 negative 25. Hopefully you can see. I'll show you with tracing paper here. Okay, so if I take this graph and reflect it across the x, and then reflect it, oops, let me line that up, across the y, just on top of itself. Is f even, odd, or neither? Well, essentially, right, an odd graph is when you get if f of x is equal to negative f of negative x, which means you're reflecting across the the x and the y axis, which is exactly what happened here. This is odd. these points again. Look, 450 becomes -4, -50. You switch the input and the output. I hope that helped, and I'll see you soon.